All right, welcome everyone. We're going to start with some notes today. I want you to go to section 6. Section 6 should be our 5.3 notes. It'll be out of the Algebra 2 book. It won't be out of our book, so it won't match. Keep that in mind. The homework has been taken a picture of, and it's added to the next worksheet down, so you'll be able to do the bookwork that's attached. It's right in your packet. Today's notes are going to explore the vertex form a little bit more. We've been able to graph it, work with it a little bit, write it a little bit. We're going to do some other things like that with it. And additionally, we're going to go ahead and change its form into standard form. It'll be something new we haven't seen today. There is an additional example I added in, so these notes will look slightly different from yours. You'll have to cram them in on the bottom. I think they'll fit right underneath where it says homework at the bottom. We'll be able to put them in there when we get there. But let's just recall real quick. With the vertex form, our A value tells us if it's narrow or wide. Right? If it was narrow, it was a whole number. We'll put just an example up there. And if it was wide, we'd put a fraction. So there's just a quick reminder of what A does. It also tells us if it's positive that it opens up. And again, I like to write this on here. This would be one of the first things I would do on the quiz, is to write this information down right at the top so that I could remember and get it out of my head. Remember that H and K is our vertex. So we'll write H and K. H is the x coordinate, K is the y coordinate. Remember that H lies to us. It tells us the opposite direction. So if it's negative inside this expression, this function here, that it's going to move to the right. And if it's positive, it's moving to the left. Remember, it lies. It tells us the opposite direction. And K is truthful. It goes up and down. If it's positive, it's up. If it's negative, it's down. All right, so that's just a quick little review. Hopefully you have your notes out and you'll be able to record that down. I'm going to scroll down just a little bit here to start the next example. So we've done this already. You did it in the vertex form homework, but we're just going to review it one more time. We're going to go ahead and attempt to graph this out of vertex form. Again, a skill necessary for your quiz. But don't forget, any function, and it's solve for y, we can just pick and make a table of x and y values. So if you ever get stuck and you forget how this works, just remember, you can pick any values of x that you want, plug them in, and you can solve for whatever y values would come out here. Okay? And then you would plot those points and you would be just fine. But we're going to use the techniques that we've learned in class. So let's go ahead and start marking down some of those. We already can tell from our a value that we can take a look. It is a fraction, 1/2. So we know it's going to be a little bit wider. So it shouldn't be, it should be a little bit wider. It should be a big fat U. We can also tell that it's a positive 1/2. This is a positive 1/2. That it's going to open upwards, which means that we're going to have a minimum for our vertex. And again, we're not going to directly use that for graphing, but it is going to help us check when we graph. We know something about it. So if we graph upside down, we did something wrong. So that'll give us an additional check. So let's find some points with this, because we need to be able to graph 5 points to make this work. So the first point we're probably going to look for is our vertex. What I would urge you to do is make sure that you are well aware that this k value is not the y-intercept. I don't want any confusion there with the quiz. Again, students commonly forget that. I've seen some of you do it in class. I want to make sure that in the vertex form, this last constant, this constant value, while it looks like it might be the y-intercept, in this form it is not. So let's go back and find our vertex. Vertex should be pretty easy to pull from here. Remember that this value lies to us, so it looks like a -2. It's going to be our h value. We'll find our k, which is that +3 we've seen. So let's go ahead and write it in. So it's going to be a +2. Remember, it lies to us where the k value tells us the truth. So our vertex is going to be 2, 3. All right. From that, we also get another piece of information, which is our axis or line of symmetry, either way. And that's always the x coordinates value. But we have to write it as a vertical line. So we're going to write x equals 2. Never write just 2. It's not quite correct. It doesn't equal a line. So let's go ahead and plot our vertex. Let's start there. So we're going to go to point 2, 3. So it should be right in here. Make a nice little point there. There's 2, 3. And let's put our axis of symmetry in as well. So we'll do a little dashed line right through that x coordinate of 2. So now we've got a good start here. Let's make that a little bit bigger so we can see it. Maybe I should even probably change its color. Let's try changing its color so we can stand out just a little bit more. All right, so there's our vertex and our axis of symmetry. All right, Now let's move on. We only have 1 point so far. We don't have a y-intercept, so we do have to find some additional points here to be able to graph it. To do that, let's find our y-intercept, and let's see if it fits right on our graph. Now this is a good practice for us because we don't have our y-intercept. It is one of our critical points, so we should always attempt to find it. And to find this, remember, every y-intercept has a 0 for the x in common, so that's what we're going to do. We're going to plug into the function 0, and we're going to evaluate it. So let's go ahead and do that. 1/2, plug in 0, minus 2 squared plus 3. If we do that quick calculation, we get 4 here. 4 divided in half is 2. 2 plus 3 is 5. So we get 5 for the value that comes out. So if we fill in our y-intercept, it's going to be 0, 5. Well, that's pretty handy because it does fit on our graph. Should fit right here. So 2, 4, and 5. This is going to be our y-intercept right here. Now remember, because we've got our axis of symmetry in here, we get buy one, get one. That means that we get a free point the same distance away from the axis of symmetry at that same y value on the other side. So we'll go 2 distances away. So there's our free point right there. So now we've got enough to make a pretty good, we could call that a graph and be done with this, but we do want to get in the habit of making sure we've got 5 points. It just makes a much nicer quadratic function for us. So we're going to find an additional point right now. So our additional point then, we're going to pick any value of x we want. Doesn't really matter what it is. So we're usually going to pick something right around the vertex because we know it's going to be close to our graph. So I'm probably going to pick the value of 1. So let's go ahead and pick 1. So now I'm going to reevaluate this function at 1 this time. So I'm going to get 1/2. There's the 1 we plugged in, minus the 2, squared plus 3. Again, if we do a quick calculation, we're going to get -1 squared, which is 1, times 1/2 is 1/2, and 1/2 plus 3 is 3.5. So our new point, I'll write it over here so we can see it all together, is 1 and 3.5. Or 3.5 for graphing is fine. So we're going to go over 1 and we're going to go up 3, which puts us on par with our vertex, and we're going to go 1/2 more, which is going to put us right here. And remember, buy one, get one free. Because we have our axis of symmetry, we're going to go right that same distance away, 1 unit away, and we're going to put another point. And now we're going to graph this. So nice smooth curve, don't make it a V-shaped, because that would indicate that it's a, oops, kind of missed. We'll see if I can straighten that out. There we go, a little better. So there's our quadratic. All right, let's move down to example number 2. I'll scroll right down here, if I can get this to work right. Here we go. So example number 2, we're going to do the reverse. This is where we're going to take and write the equation from the graph. We did a little bit of this in that vertex form activity, but we're going to practice again today. So to write the equation of a parabola, we can really only do it in vertex form. So we're going to start by identifying the vertex, which we can see right there is going to be 3, 4. So we're going to go ahead and start to write that in. Remember, our vertex form is y equals a times x minus h, that quantity squared, plus k. So we'll start by writing that in. So we know y equals, we don't know the a value yet. We don't, well, we will find an x value here in a second. But we do know h, so minus 3 squared plus our k value. And again, remember when we write 3, it's positive here. When we put it into the vertex form, it lies to us, so it'll be the opposite sign. So that's what we've got so far. To finish writing the equation of this parabola, we have to know a value. Once we know, oops, except for I wrote k as k instead of k as 4. So let's write it in correct. So there's our 4. So we do have to know the a value. The x and the y, those are inputs and our outputs, so we never really write those in for the function part. But we do need to know this a value. So there's one unknown we need to find. But right now we have 3 unknowns. 1, 2, 3. We have the y, the a, and the x. But if we go back over here to the graph, they so kindly give us another 2 values. They give us an x value and a y value. So what we're going to do is we're going to plug those in. In the vertex form activity, we saw that we could find that from the first difference, which was much easier. But since we don't have a table of values, we have to do it by plugging in a y value and an x value and calculating what a will be. So that's what I'm doing now. I just plugged in the x and y value, and I'm rewriting it. So there's our new one. Notice we've got one unknown, one equation, so we can solve for it. So we'll go ahead and clean this up and solve it out so that we can find out what this is going to look like. So 5 minus 3 is 2. So let's move over here. So equals A. So we'll have a positive 2 squared is 4. So I'm just going to go ahead and change that to 4 now. Plus 4, which is right here. All right, so now that we've got that, we're going to do reverse order of operations. Remember, that's how we solve for things, and right now we're solving for A. And we're also going to use inverse operations as we're solving. So we're going to use those two properties. So the first thing we need to address then is this positive 4. So we're going to move that off to the other side. Remember, those turn to 0, so it's gone on that side. So we're going to get negative 8 equals 4A. Now I'm going to address this 4. I'm going to end up dividing it off. So I'm going to cheat here. I don't have a lot of room, so I'm going to divide 4 on both sides. I know it's not the way I like to write it, but it'll work. So we get negative 2 left on the left side. Negative 8 divided by 4 is 2, negative 2. And these two 4s will reduce to 1, so we find out that A is equal to negative 2. So at that point, we've got everything we need. So we're going to rewrite the equation with out the x and the y, because remember, we don't actually want to write those in there. So y is going to equal negative 2 times our x value minus the 3 we already found and plus the 4 we already found. So there's the first part. There is the vertex form. But it does ask us to find one more thing, which is the axis of symmetry. And that's really not too difficult for us because we already have the x coordinate of the vertex. Again, it's 3. So our axis of symmetry in this case is 3. And so there's the two parts we need for that example. So remember, when you're finding it from a graph, you got to have the vertex. You got to be able to locate that, and you have to have one additional point that we need to be able to use. All right, so let's move down to example 3. There we go. Example 3 then. This is the last one on your page. 4 is the new one, so this is the one you're going to have to squeeze in. Okay, we'll come back to that in a second. Now what we're going to do is we're going to practice taking this in standard form and writing it into vertex form. Sometimes that's handy, something that we might want to use because it's quicker to graph a lot of times, a lot easier for us. So it is a nice skill to have. So let's go ahead and attempt to write this out. To get this into vertex form, we're going to do something that we already know how to do. We're going to find the vertex, right? And we know how to find the vertex. We learned that before. We said that the h value and the k value we can find by doing this. We said that if we found opposite b over 2a, that would give us our h value. And then we would plug whatever that number came out to be, we'll plug it into our function. So since I don't know what it is yet, I'm just going to write opposite b over 2a. And then this would be our vertex. And that's really all we need, because guess what else we already have? We already have a. A is equal to 2. Let's write down the other coefficients while we're at it, because we need them for, well, at least we need b anyway, which is 8. Oh, one more thing, as I just noticed. Let me write down c really quick. There's c. Change this value on your paper. You have a 10. Please change that to an 8 so that you can match mine. Okay. So now let's go ahead and finish finding this vertex now. So I'm going to do opposite b over 2a. So it's going to be my x value. So opposite b is negative 8 over twice my a value, which is 2. So that's going to be negative 8 divided by 4, which is going to give me a negative 2. So there's the first part of my vertex. Now I'm going to find my y value, right? My k value. So I'm going to plug that in. I'll change my color for you. So I'm going to plug that in. So I'm going to take the function. I'm going to evaluate it this time at negative 2. Right? That's this part where we're working at right now. So negative 2 then. We're going to plug that in where we see an x value. So 2 times a negative 2 squared plus 8 times negative 2 plus 7. Okay? So we calculate that out. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16. And there's that positive 7. So if we simplify it one more step, we'll combine those two. We'll get a negative 8 plus 7, or is equal to negative 1. So now we have our vertex. We'll write it right here. So our vertex for this one then is negative 2 -1. So now that we have our vertex and we have our a value, we can write the form. So that was really pretty quick and easy. All we had to do was find that vertex. So here we go, writing it in the form. I'll change my color again. So the new function then would be y equals our a value, which is 2, times x minus our x coordinate of our vertex, which is -2. So remember it lies to us inside, so we're going to put +2, square it, and remember that our k value tells the truth, so we'll put -1. So there is your vertex form from standard form. All right. Now, the last question that we're going to do, so take a second, write this in. So we're going to take 3 times the quantity of x minus 2 squared minus 4, and we're going to write it in standard form. So we're doing the reverse of what we just did, right? So this one's actually doesn't require anything that you already don't know. I guess what I'm saying is you already know how to do this. We're just going to multiply this out. We're just going to use order of operations, right? We're just going to go down the system order of operations. We're going to multiply out all of our squares, multiply anything that is a distributive property, combine any like terms, and we're done. Okay? So first thing that we're going to address here is we're going to take this value. It's a binomial squared. We did learn that when we did our multiplication, and we talked about it a lot with our factoring as well. So let's go ahead and start that process again. Binomial squared. So we're going to take this, and we've got that binomial squared trick, or you can use some of the other techniques that you've learned before. Not my favorite, but FOIL will work. You could also multiply it out using that box. We've done it that way, or double distributive property. I'm going to use the square of a binomial because I'm okay with it. So I'm going to go ahead and do it. So I'm going to write my 3 down. Square binomial says that I'm going to take the first term, it's going to square. I'm going to take the 2 terms, multiply them together, and double it. So that's going to give me 2 times x is 2x, times 2 is going to be 4x, -4x. And then I'm going to square my last term, which is going to be +4. And then I'm going to subtract that 4 that's at the end. Okay, so now that we've got that done, we're going to do this distributive property. So we're going to multiply 3 to all the different parts in here. So we're going to multiply 3 to all 3 terms. So I'm going to get 3x squared minus 12x plus 12. And then there's that -4 we got left over. So now I'm going to combine any like terms, which are just the constant terms here. So I'm going to end up with 3x squared minus 12x. And I'm going to get plus 8. Okay? And so that is... Okay, so now we've got that in standard form. One quick thing that I want to show you is that if you pull up your calculator, you can double check any of this work at any point in time. So if you turn it on, you can just type into your calculator both forms of the function, and you can double check if it graphs over the top of itself. So looking at the one that we just did here, looking at the last one we did, because I already pre-typed in, you can see here, we went from standard form, 2x squared plus 8x plus 7, 2x squared plus 8x plus 7. And then I also typed in what we found for the vertex form, 2 times the quantity of x plus 2 squared minus 1, 2 times the quantity of x plus 2 squared minus 1. And I've changed that one line. Remember, we've talked about this before. This is a darker line. So when I hit graph, and I highlight both of these functions and turn them on, you're going to see the line graph. So there is our first one, and then the dark one went really quick over the top of it, but you saw that it graphed both of those. Again, see if I can get it to do it again. It probably won't. But you can double check it that way by visual representation. Then you can also check, really the nice way to do it is to look to see if all your table values match. That way it's a little bit more accurate. So your calculator can be a little assistance there when you get to the quiz and or you're checking your problems. All right, that's it for me. I do want to make one more note here. I did change the homework a bit for you. It's still 1 through 35 odds. I did shorten it a bit. I took off there a couple problems through 41 there. But what I did instead is I want you to take 1 through 11 and I want you to write them in standard form. Those directions are not on the page. I'll scroll down to it. Here's the page. It should be the next one in your packet. So for this section here, I want you to write these in standard form. Okay, additionally. So you're going to graph it like it says at the directions, the odd ones, and then you're going to write in standard form. I'm going to write it over on the side. Write in standard form. So you're going to multiply them out like the last example. And then there's a couple more down here. where you're going to write in vertex form. So you've got both of those form changes. All right, good luck with your homework, and I will see you on Monday. Bye all.